Minasan, konnichiwa. Zamurai Engineer desu. So in this video, let us move to the next module number 9, and let's talk about nominal strengths. So I'm your professor, Dr. EYPEI ZANTUA, and we're here at Taguig City University. And let's start the discussion by again repeating our objective of the course. This course would provide fundamental concepts, principles, and theories under structural analysis and design of steel elements in a structure. There are 8 major topics. We are already in major topic number 2. Under this, we are now on module number 9 about nominal strengths. What do you mean by nominal strength? Nominal strength is a calculated theoretical strength, okay, with no safety factors, omega s, or resistance factors, phi s applied. So, meaning to say, it is strength before application of safety factors. And again, there are 2 specific approach on this side. So in LRFD, that is load and resistance factor design, a resistance factor usually less than 1.0 is applied by the nominal strength of a member. While in ASD or allowable stress design, the nominal strength is divided by a safety factor usually greater than 1.0. Okay. So since in ASD the safety factor is a divisor, so it is bigger than 1.0. Okay, so that is in opposite with what is happening in LRFD. So why? The reason for this is to account for variations in several areas. For example, material strength. Okay. Every material we can have variation in strength. Even though steel is the most studied material, and because of that, it gained more and more precision in producing specific steel products. However, we cannot deny that still we have errors or variations that we need to take into consideration. Another thing is the dimensional variation. It is not very hard to imagine dimension varies in actual, particularly inside what construction, so on-site construction. Even in what factory production line, there are some sort of variation that happens. Next is workmanship. Okay, so because different person will handle it differently, the person's skill varies, therefore there are variation. Okay, and persons would tend to get tired, so different level of tiredness will give us different result pertaining to quality. And also the manner and consequences of failure. So because there's no two projects that would fail at exactly the same way and just exactly the same consequences. What are the property that were affected by a particular failure? What are the fatalities? How many are injured? Something like that. So those are consequences. How much was the cost of the losses due to failure? So those are variable. There are variation. We cannot expect it to be constant or common for each and every project. So because of those things, we have to take into consideration the different safety factor, and since we are going to apply safety factor, we need theoretical strength value, which is what we call nominal strength. And here we just have to inform everyone that we are using a textbook wherein we are presenting, the textbook is presenting two approaches, LRFD and ASD method, and in the book, ASD is shaded because the numbers in the steel manual pertaining to that method are also shaded. So the book used that same policy. So actually that is not shaded in the code. Instead, those are what? With green color. Okay. So now we are on the last slide for the material engineer challenge question. Question number 7. Cement mortar for stone masonry shall be used within blank minutes of preparation. Cement mortar for stone masonry shall be used within blank minutes of preparation. So, cement mortar, meaning that is the mixture of cement and sand that is going to be used as a paste for stone masonry. The answer is A, 30 minutes, B, 45 minutes, C, 60 minutes, D, 90 minutes. That's all about this video. Again, this is Dr. EYPEI, preaching engineering for nation building. See you on our next module. Thank you.